and slightly different because they've moved the, not here, but on the other one that it says I work for AWS DevOps. I work for AWS, and DevOps was the title of the presentation. Very pleased to be here. As I've been introduced, my name is Paul Ahlgren. I come from Sweden, and I work for AWS. And this talk is going to be a little bit about the history of DevOps and the reason why it's absolutely a necessity if you're moving, or rather when you're moving to the cloud, if you want to be successful. Normally, as you heard of the presentation, I normally introduce these days as an industry veteran, which is just another word for being an old guy. Been around. One of the things I realized when I was listening to the AI girl in the keynote, she said this quantum computer, it was huge, 3 times 3 meters. When I started, that was a mini computer. I've been working with those for many years on that company that you see up there. This presentation will not look perfect, and the reason for this one is that the computer where they have the presentation on, it doesn't have the fonts that the presentation was made of. So when things are looking like this, it's not that I'm completely incompetent of making a presentation. It has to do with that it actually have changed things. But I worked 17 years for Digital, which if you're younger than 45, have never heard of, but it was the second largest computer company in the world after IBM for about 30 years. And I've been around since the beginning of the 80s. So this is a little bit about me, and I'm going to go on instead to the subject of today, which is DevOps. DevOps may be a fairly new word. It actually celebrates its 10th year's anniversary this year, but the practice is old. I did DevOps in the 80s. And if you're a mainframe programmer and been working with IBM, they've been having also since the 80s a tool called Endeavor, which was DevOps. So the practice is an old one. We've been trying to make it simple to deploy software, but we've been doing it for quite some time. What it's all about is automation. And why is automation important? Well, it reduces the possibility of error. And in the cloud world, it also increases the possibility of security, of being secure. Because the thing is that DevOps today, when you move to the cloud, it's not just deploying software. You're deploying your security measures, your firewalls, your networks, your machines, your databases. Everything is deployed automatically through DevOps. Not only the code and the things that the code run on, but the full environment. So for instance, in the cloud, you normally, if you have test environments that you only use every now and then, you don't have them up, because as soon as you take them away, you don't pay for them, since the cloud is consumption only, which means that if you don't run it, it will not cost you money. So what people do today is that they describe their full test environment with security, everything. And if it's not an environment that is used all the time, what they do is they take a backup of the data, kill the whole environment, and then bring it back up a couple of months later when they need it. This is modern DevOps. So it's not the DevOps which most people think of deploying software. That's just a part of it, but it's definitely not all of it. But if we look what is DevOps? It started with actually point number 2, that you wanted to build your software in the rare instance that it was anything but a single program. When I started to program in the beginning of the 80s, it was still pretty common. You had source files that were 5,000 lines long and had everything, including your subroutines and everything. So what you did when you wanted to build was just to say, if I did it in C, I did CC space the file name pop done. So that was how it started. But then the program started to split up, so you needed to build and link the programs. And it started there that you started to do scripting to handle those things. Also in the 80s, the code management came along, and the code management tools was so advanced at the time, so you could actually extract the data with the script, build it, and do all the stuff. So that is all how it started. Testing was completely unknown at the time. But when you do test ops, you have all of these 7, of which most people think of the release as the whole thing, where we look at it today. But it's all of these. And all in all, in the end, it's all about this, that it's about getting quality and governance. This is what you gain. And it's an absolute necessity in the cloud, and you will understand that in a few minutes when I get to the next set of questions. So, what are the goals with DevOps? As I said, it's things like you want quicker deployment. When I started working at Skandiabanken, they hadn't worked with DevOps at all. They could hardly build the whole bank in one go, or rather they couldn't build the bank in one go. So me and a few other guys, we set out to change that. And in 3 years' time, we went from the thing that we could release the bank about once every 2 months to at least once a day with full compliance. Because releasing once a day, most young people say, well, that's not hard. That we can do. I mean, we do continuous deployment. We continue every time someone checks in. We do this. Yes, but if you're running a bank, you also have to be compliant when it comes to documentation and, who has requested the change, who has made the change, who has reviewed the change, who has said okay to the change to go to production. And so we were pretty proud to get it down to 1 day with all that documentation in place. So the quicker deployment is one of the most important things. And into that goes faster time to market. Today, we have customers which put up pop-up stores on the net. And in their case, the thing is that they may have something, they have to put it out, special custom-built website for some special kind of shoes, for instance. So they need to quickly get it up, announce it on social media. A lot of people go there, they have to scale, and to be able to do this, and to be able to do this in scale so they can do it for different companies, they have done everything with DevOps to be sure that they can go out very quickly and repeat what they're doing. And the other things I think I skip. And unfortunately, there's an ugly truth with this. If your company hasn't worked with DevOps and want to get started, because it looks good that you can build your software, get it out, and all this, it takes time. As I said, for Skandiabanken, it took us 3 years to get almost everything automatic. We had to give up on one thing, but instead we killed that product and took it out of the equation because we couldn't get, and it wasn't really the product's fault, it was Microsoft BizTalk server. It wasn't really the product's fault, but the environment that had been built up for over almost more than 10 years was in a state that nobody really dared to touch it. So we didn't dare to go in with automatic deployment. So we had to skip that. But all the rest, we did. The most difficult thing when you do this journey is a few things that you have to learn, which is if you come from the old world, it's pretty tricky. Because the most tricky part is that you have to learn to be always backward compatible. That is, for instance, why many people left SOAP and went to REST. If we go beside the point of that REST will help you with links and other things, state. So one of the big things with REST compared to SOAP was that it's much easier to make it backward compatible, because any change that isn't breaking anything, like if you add fields on the back of your message, the old clients won't care. They will just ignore it. So that's one of the things you have to do. But the most difficult thing to change if you're doing this journey is that you have to learn to make your databases backward compatible so that you can do upgrades without breaking the clients. And that is tough, because this is not, database people are not used to this at all. They're used to that they can shift in things and that they, if it's really breaking, that they can, take the data, make a new table, move the data. And that doesn't really work in the DevOps world. So you have to think when you do changes in the database on how you're going to do that. So, and here is my paraphrase on Enter Sandman with Metallica. Instead we say exit ground and enter cloud. The cloud has changed a lot in architecture, because if you think that the cloud is just another data center, you're dead wrong. That's what people who wants to stay on the ground thinks. If you take a developer, they see no servers anywhere. Modern applications don't have servers. You don't need them. Databases can be serverless. Your messaging is serverless. Your functions, instead of running it as web services, you run it as lambdas in our case, where it functions as service. There is no service visible for you. It scales automatically. If you need 10,000 servers, that works as well. But the thing is that the cloud is such a different beast that it has changed how we do architecture quite a lot. So, to get you to understand this, I will move back to the good old days. How many programmed in the 80s? Anyone in here? That's nice. Well, then you remember that most programs was a single program, and most applications was a single program that you used. And for instance, I'm that old that it wasn't really, unless you were in the IBM world, you normally didn't even use databases. You used flat files with indexing. Damn fast things that you can do things. And the one that starts to think that, well, isn't that document databases? And yes, the idea to document databases isn't anything new. It's more than 40 years old, the idea. So we used flat files. You didn't really need much of a thing here, because as I said, most programs were you built it and you run it. So you built it and then you copied it into the right place. That was about the whole process. This was on mini computers, by the way, no PCs. Then there came this amazing concept about client-server computing. You should run stuff in the middle, and then you had your clients, which wasn't a PC, by the way, because the client was a workstation, which ran Unix or VMS or some other operating system, because you did real computing on workstations. PCs was some kind of toy that some people used. But suddenly the things were separated. And if you were ambitious, you could compile the different programs and you could copy them over and into the systems if you like. But the systems were still pretty stable. And the server wasn't the services we used to. It was more of a convenience routines to get to the database, so that you didn't have to do that in many cases. And then we move on to a concept that is still considered fairly modern, which I is seriously interested why people think this, because it's about 20 years old. And this is when you have services and you have other services talking to your services, or it can be a web or a client, and then you separated down the database into separate clusters and all this. And in this world, this is where DevOps for real was born, because suddenly you had and this is actually how the Skandia Banken, where I was, this is how more or less how we built this. And we're talking about 700 services. We're talking about 800-900 web pages, 20-30 applications on the client side, and about 15 or 20 databases on the back-end side. And to be able to do that, you really needed DevOps, and this is what we put in there. But this is still a fairly controllable environment, and you're talking software. So let's move on to how it looks today. This is an application. Perfectly valid, normal application. I've stolen this, so I have no idea what it does. It's just that it has a lot of our good symbols, and it has the complexity to get my point through. This is how applications looks today. And the reason for this is that the services are no longer packaged into service applications. Instead, every service stands by itself. Another thing that is different is also that one of the things when you work with databases, and that was so important if you worked with the relationship databases, was that the fact that you committed things. You wanted to be sure that it was committed, for instance, in both two databases at the same time. So you did what's called a two-phase commit, where you ensure that it has been written properly into both databases. And then you commit the transaction, and it puts everything down. That is completely gone. Because the thing is, with the cloud and with the scale of modern applications around the world, it doesn't work anymore. So everything is eventually consistent. You will write to the customer database knowing that the order will probably be in the order database in a second or in 5 minutes, but it will be there. And the reason for this is that everything has to scale individually. And why does it do that? Well, the thing is that if we go back to this picture, with the service application, what happens is that you scale for peak, and if you have 50 services in the box on the left-hand side here, you have 50 services. One is really hot. That is where you put your orders in, right? And then you have a few ones which has this change address and things you do once a year. The thing is, when you put and when you provision that server or servers, you will have to scale for the big one. And when you move to this world, the thing is that the big one won't fit anywhere because it will be so big, it will take up so much resources, and it will kill the other ones. So everything is now separated, so everything can scale individually. And the reason for this is also the fact that, and I'm going back and forth, in this world, you normally pay for the server. What you put on it, you don't care. In this world, you pay for the transactions. Every single transaction. The cloud is consumer-based. Principally, no licensing, no upfront cost. And that has created a completely different world where you have to do things like this. So to be able to handle a world where your application that used to be 5 boxes is suddenly 400 individual items that are processed, including the fact that it's not just the software, you are going to take care of security, and you're going to take care of networking, and you're going to take care of everything. That is why you need DevOps. And how do we do this? Well, I will take another example, since I have 10 minutes left. I will take an example on also how architecture has changed. Because I've been an architect, as you heard, for about 30 years. An architect in the old world has very much been a person, since we're going to be inclusive, a person that makes compromise. And the most famous and most common compromise is the database. The thing is that for many, many years, and I've been working with relationship databases for over 30, it has been the jack of all tools. The thing is that you have your ordering system in there, you have your logs, you do your data warehousing, and you do audit trail, everything. And it's done in one database. The most common reason for this is that a company like Scandia, where I was working, they said that you can use any database you like as long as it's SQL Server. So we did everything in SQL Server. Excellent database, no doubt about that. I've been working with it for a long, long time, and I like it. But the thing is that it was a compromise, because out of these 4 things, there is only one for which the relationship database is made for. So in the new world, the thing is that we compare this to the thing on the left. That's the wrench, the one where you always you shift it back and forth, and whatever you want to do, it's not really good, right? A professional car mechanic, he has fixed jacks, so he can, the right tool for the right job. And this is what happens in the cloud. The thing is that the solution to the right, and I'm going to explain what it is probably cheaper than the thing on the left, while it does the job much, much better. And the thing is that your order system, you will still keep that in a relationship database. And the logs, you will put that in a document database. Could be DynamoDB if you're in the AWS cloud, and there are MongoDB, and there is a number of databases in this area. The data warehousing, this is where the relationship databases is a terrible idea for data warehousing. And the reason for this is that a relationship database is row-based. It's extremely fast of getting a row. So it looks for my name, bump, get the customer record for me. That's what a relationship database is good at. What a relationship database is not good at, and which we try to say by using indexes, is that saying, I want all sales in Reykjavik in the month of January, where the person that bought this paid with a credit card. We do this with indexes, and it makes the databases slow, because that's not the way it's supposed to work. And questions of this type can take quite a long time if you have 10 or 50 million records you're looking through. Instead, you should use a column-based database where everything is turned around to be scalable on column by column. We have something called Redshift. There are other, Snowflake and others out there. And the whole idea is that they are made so that if you make a query like the one I told you about, it will scale out maybe to 30, 40 machines and doing the query. And the query that took maybe an hour to run in a relationship database, you have an answer within less than a second. And then if we go for audit trails is to prove that you really have control of what you're doing. We have something called a quantum ledger database, which actually keeps a log of every change in the database, so you can actually see who changed it, what did they change, and when did they change that. And that is audit trailing if you're working with a bank. The solution to the right is how you design today. You should use the right tool for the right job instead of trying to fix everything into one. And this has changed also, which means that, well, instead of one database, you now have 4 or 5 databases you're going to push things into. Devops come to the rescue for that one as well. And where are we now? Yes, I've already told you this, that there is so much more than just the software that you do. And also one thing that is good to know is that the cloud is really built for doing rolling upgrades, which is not visible for the customer. You can do blue-green, you can do canary, you can do traditional rolling, you can do rolling with that. If we upgrade 100 servers, when will it be considered that we failed? The first server that fails the upgrade, or after a certain percentage. You can do those kind of things as well, that you say, it's okay that 3 servers out of my 100 fail. I will take care of them later. That's still considered a successful upgrade. You can do those kind of things. So you have a lot of interesting things you can do when you do this stuff. And how do we do this? Because you realize, if you have ever been close to this, that it's a complex environment, right? Well, it's something called infrastructure as code, where infrastructure is described as code, and then you can treat it as code, so you can version control it. So if you have a company which, for instance, put up versions of software, and your customers refuse to upgrade, anyone that worked in a product company knows that this is very often the case. Today, you have an environment that is 5 years old that sits there and runs, and if you get a problem. With infrastructure as code, you save the code on how this looks, and when you get that problem, you take the script for the version that was 5 years ago, you hit it, you run it, spin up all the resources. You have an environment that is made for version 1.5 of the software while you're normally running on 4.0. This is infrastructure as code. You can take it up, you fix the problem, and you kill the whole environment. As I said, you take it away again. So you kill the whole environment, and you have fixed the customer problems, send out the patch, and you don't have to pay for that environment that you normally don't use. And the thing with this is that there is a number of products that do this and do all of these things. Ours is called CloudFormation. There are Terraform, Hero, Puppet, Chef. There is a number of them working in this space. So the important thing is that you have to realize this, that it's not just software. You have to look at the full environment to really scale in the cloud. And also it's not just that it scales, it also has to be that you save money. Everything we do is trying to see to that our customers don't overspend. We constantly give them the opportunity to optimize the environment. We give free advice by machine learning saying that you're running the wrong systems here. You should go down because you're paying too much compared to the load you're running. So, and the thing with the DevOps is also to go into that space of see to it that you don't spend more than you need. And this is just a little introduction on why DevOps is so important. So if your company do not use DevOps, independently if you're on-premise or if you're in the cloud, you should seriously look into this because it will be safer, it will be quicker, and you will be happier when things actually deploy and work. Thank you.